Good evening, everyone. Today we are going to talk about qualitative analysis, alternative to practical chemistry. Last time I said that we have test, observation, and inference. The test, observation, and inference. You may not know what you have here, and here. If you are not good at the basic knowledge of acids, bases, salts, oxidizing and reducing agents. So at the end of this lesson, you will be able to learn what you may have as test, what will be the observation, and how to draw your inference. So join me now as I take it very easy to teach you these basic things, because without them you can't fill the table in any qualitative analysis, be it qualitative analysis alternative to practical or the main practical in the laboratory. So we are going to talk about acids, bases, and salts. We're also going to talk about oxidizing agents, oxidizing agents, reducing agents, as well as precipitating agents. With the knowledge of these and metals, you will be able to fill or carry out any experiment on salts analysis. Now, we don't have to touch these ones this moment. Let's talk about acids, bases, and salts very quickly and in a very short form that will guide us to a successful filling of the tables. Now, I want to talk about acids. An acid is a substance that ionizes in water to produce hydrogen ion. Ionizes in water, dissolves in water to produce hydrogen ion. Now, the strong acids that we use most of the time in qualitative analysis are tetraoxosulfate acid, triazonitrate 5 acid, and hydrochloric acid. Tetraoxosulfate acid, triazonitrate 5 acid, and hydrochloric acid. These acids ionize completely to produce hydrogen ion. Now, we may not talk about basicity of an acid because of our time and because we want to go straight to that qualitative analysis. So other acids are weak acids. The weak acids we have triazocarbonate 4 acid, we have hydrogen fluoride, we have hydrogen sulfide. These are weak acids. But now we are going to be talking more about these ones. In any kind of reaction, when you have tetraoxosulfate acid, when it acts on any substance that has chloride, it can dissolve it. But when you have SO4 in the reaction and you try to add HCl, it cannot dissolve it. We are going to see that in our subsequent class. Now we want to talk about the base in this qualitative analysis. The bases we use are mainly sodium hydroxide. You use sodium hydroxide mainly. Then you use ammonia solution, ammonia and ammonium hydroxide. We use these in the experiments. These are the bases we use, and this is a very strong base. We use this in precipitating metallic ions. Then we are going now to talk about salts. So take note of all these because they are going to help us when we will now enter the table and the analysis. I want us to briefly talk about salts. Now, the salts that we are going to talk about, I want to bring it in a larger form. So let me clean these ones. Because qualitative analysis is mainly on salts. The salts that we are going to talk about, we have normal salts. The normal salts are those that have enough acid to react with the bases to form the salts. When you have sufficient acid with sufficient base, just like we all know, when this hydrochloric acid reacts with sodium hydroxide, which is an alkali or base, we call it alkali, a basic hydroxide that is soluble in water, alkali, it will give us salt. and water. This is a normal salt. But you can have acid salt when in this form. You have something like this. Sodium hydrogen tetraoxosulfate. This is an acid salt. Look at it. This is an acid salt. Acid salt. You can have basic salt when you have something like this. See, basic salt. You can also have double salt. You can also have complex salt, that has a salt that has complex ion. But we're not going to look at this. These are the salts. Other substances, we also have this as salt, silver triazonitrate 5, normal salt, lead 2 triazonitrate 5, a normal salt, and many other ones. You also have barium chloride. I know why I'm mentioning these ones, because these are the ones that we use most of the time. We have zinc triazocarbonate 4 salts, a normal salt, calcium triazocarbonate 4 salt. All these ones are normal salts. So our experiment will base more on these normal salts. And this is what we always talk about when we talk about qualitative analysis, GC. Most of the time we use these salts and the other normal salts in our analysis. Now I want us to go into another thing that is very important under salts. Another thing that is very important under salts is what we call soluble and insoluble salts. We are getting there. So keep following us. Please, if you have not subscribed, do it now. Like this video and share it. Let others also acquire the knowledge you are acquiring now. So let's look at the soluble and insoluble salts. Soluble and insoluble salts. Once again, pay serious attention because we are getting there now. Any salt that contains Na, sodium, any salt that contains potassium, K, any salt that contains NH4 is soluble. Let me give you an instance. Ordinarily, any salt that contains CO3 is not soluble, but if it is Na2CO3, sodium triazocarbonate 4, this one is soluble. Look at it. It's a soluble salt because it has Na. Now, any salt that contains NO3, triazonitrate 5, or triazonitrate 5 salt, anywhere you see NO3, it means that salt is soluble. This, anywhere you see NO3, it is soluble. Take note of this. NO3, always soluble. So if you dissolve it in water, it will dissolve. Now, other salts that are soluble are, watch now, we are going to enter the next step, that some are soluble, some are not soluble. Tetraoxosulfate 6, SO4 salts, tetraoxosulfate 6 salts. Tetraoxosulfate 6 salts are soluble except barium, BaSO4. This one is not soluble. BaSO4. Now watch, let me show you something now very quickly. This barium chloride is a precipitating reagent. It is used to bring a precipitate of SO4. So in a situation where I have something like sodium chloride, okay, let me say I have sodium tetraoxosulfate 6. If I add barium chloride to it, it will give me a precipitate, BaSO4, which is an insoluble salt. If I have sodium chloride like this, I will use barium chloride to precipitate this SO4 ion to SO4. So I will use barium chloride. If I add the two, it will give me this precipitate, barium tetraoxosulfate 6, S precipitate. Then I can continue the analysis. Please take note of this. So this is an insoluble salt. Now, all chloride salts, Cl salts that have Cl, they are very, very soluble, except silver chloride, AgCl, and lead 2 chloride, and as well mercury 1. But let me use these two for now. That is why most of the time when we want to precipitate chloride salts, Cl, we use this precipitating reagent, AgNO3, silver triazonitrate 5. Anytime you see this AgNO3, It means that they want to precipitate Cl. Take note, anytime you see silver 25, it means we want to bring out this chloride, because when these two combine with a chloride, this thing, it will form an insoluble salt, silver chloride. Take very good note of these. These are the things that we are bringing out now. We are bringing them out now. Now, to some extent, if I may add, this salt, calcium tetrahydrosulfate 6. For those of you that will be doing other exams, this one is slightly soluble. So now that you have learned soluble and this, so now let's go to the all sorts. These ones are soluble, as I said earlier, and ammonium triisocarbonate 4. These ones are soluble. Any other CO3 is not soluble. All other CO3 salts are not soluble. So these are the only soluble CO3 salts: sodium triisocarbonate 4, potassium triisocarbonate 4, and ammonium triisocarbonate 4. Any other one apart from these, not soluble. That is why when you have a substance like calcium triisocarbonate 4, and it's a mixture with sodium chloride, if these two are mixed, when you add water to it, you are going to have something like this. Here is your residue. Here is your filtrate. Residue filtrate. This residue is this soluble salt, which is this. This residue is this insoluble salt. Talk about oxidizing agents that we are going to use. I'm not going to mention all of them, but let me mention the basic ones. Look at this. Potassium heptaoxodichromate. I name it again. Potassium heptaoxodichromate 6. 6 is the oxidation state, but it has to be acidified in our experiments. Potassium tetraoxomanganate 7. That is oxidation state. Potassium tetraoxomanganate 7. If you don't know how to name all these, you check our previous lessons where I taught students how to name inorganic compounds. These are the oxidizing agents we use most of the time in qualitative analysis. If we want to talk about other oxidizing agents, we talk about oxygen and non-metals, but these are the ones that we talk about most of the time. What does it mean? Let me just briefly say something about these oxidizing agents. These oxidizing agents will increase oxidation states of substances. That's what it means. Example, when you have iron 2 ion, if you add oxidizing agent acidified, we acidify these agents with concentrated tetraoxosulfate 6 acid. We use this, add it in drops to this, then it will give you. So if you add oxidizing agent to this iron 2, it will oxidize it to iron 3 ion. It will increase the oxidation state from 2 to 3. 2 to 3. This is what these things will do. So this one, it will change the color of this from dirty green to brown. Dirty green to brown. So there will be color change. We are going to also see it. So anytime you see this in qualitative analysis, your mind should go, oxidizing agent. And if you see anything like iron 2, the color will change to brown, or as we may say sometimes, reddish brown. So take note of these. Then let's talk about the reducing agents. Reducing agents we use most of the time. The ones we use most of the time. The reducing agents will decrease the oxidation state. The ones we talk about most of the time, hydrogen sulfide and sulfur oxide. This is the one that we use most of the time in Nigeria here. This one. Most of the time in qualitative analysis, we use this one. It is a reducing agent. Now, let me just say it very quickly. This has rotten egg smell. It smells like a rotten egg, hydrogen sulfide. Now, look at this. Let me quickly bring this. These two are reducing agents, but most of the time students get confused because they show the same reaction to amphoteric oxides, metals. Now look at this. What this hydrogen sulfide does is what this SO4 does, but what differentiates it is the presence of lead. If it is lead, if it is aluminium, it will give you the same thing. If it is zinc, it can give you the same thing. But if it is lead, something will happen. If it is with hydrogen sulfide, it will turn black, forming lead 2 sulfide, PBS. Hydrogen sulfide, this thing, the solution, if you have NO3 like this, react it with hydrogen sulfide, it will turn black. This thing is black, has black color. So that is this. But if it is any of these ones with other radicals, there will be no visible reaction. But with this one now, it will turn black. But with SO2, there will be no visible reaction. So that is what we use in differentiating hydrogen sulfide and SO2. Lead differentiates these two. If lead is present there, it will turn black. Lead 2 sulfide, black. So this is what makes us to differentiate the action of these two in inorganic chemistry, to be precise. So now that you have learned acids, bases, salts, oxidizing agents, and reducing agents, we may now have to go into the proper analysis of this. But please, as it is right now, I want you to digest what we have done. Now, in our next class, we will draw the table, put every other thing that you may need to do, and we'll now start applying. We'll start application. In our next class, I will start with the precipitating reagents. When I give you precipitating reagents, we'll now go into the table. When we go into the table, you will surely get it 100%. Please subscribe, like, and share. Thank you very much.